was cold and windy. There was rain in the forecast. But they didn't care. Most of the crowd had been camped out overnight, guarding their places in line, swapping stories of the last time they were all here. The air was thick with anticipation. They could barely contain their excitement. No, it wasn't the long-awaited announcement of a cutting-edge smartphone. They weren't here for front-row seats at the hottest rock concert. It wasn't even a sneak preview of a summer blockbuster movie. This crowd had something much more intriguing in mind. That's right, Infineon was launching a new generation of RF transistors. Hi, I'm Amelia Dalton, host of Chalk Talk. Okay, maybe people don't really camp out overnight lining up for each new generation of RF transistors. Although that would be kind of fun, right? But if you're trying to design the latest generation of Wi-Fi, you're probably excited enough about reducing noise and increasing gain that you'd be willing to line up for, are you ready? The 8th generation of Infineon's high-performance RF transistors. My guest today is Andrew Nelson from Infineon, and we're going to talk about the latest and greatest in RF transistors for LNA applications. I know, I usually talk about chips with dozens or even hundreds of pins, and you're wondering if we can make this transistor thing interesting. But stick around, my friends. Fewer pins, more fun. Before we get started, I want to remind everyone that you can click that link. There you can download several application notes that further expand on this topic. Welcome, Andrew. Thank you so much for joining me today.
Yes, thank you.
So, the latest generations of Wi-Fi pose some serious challenges in the RF area, right? I see today we'll be talking about the new 8th generation transistors, and I understand this is targeting those of us who are doing Wi-Fi designs. Is that right?
Yes, absolutely. Our new 8th generation of transistors are specifically designed for WLAN applications in the 2.4 and 5 gig frequencies.
Okay.
These also provide great flexibility and a good price-performance ratio. And we're also very, very proud of the noise figures that these devices can offer.
Fantastic. So, since we're talking about the 8th generation, I can assume there were 7 other generations?
Yes, that's correct. And with each generation, we've managed to improve our devices. And as a result, today, our 8th generation is the best transistor product that we have ever offered.
So you guys are coming out with a new generation is kind of a big deal, right? Are engineers lining up around the block for each new release?
Yes, absolutely. In fact, they're going all the way to Munich for them.
Excellent. So, Andrew, there must be some big differentiators making folks super excited when a new generation comes out, right?
Absolutely. There's 4 different key features that we're very, very proud of.
Okay.
Specifically, the gain of our RF transistors. It's one of the highest available.
Okay, and gain is our friend, right?
Yes, absolutely. Gain is definitely our friend, along with noise figure. Noise figure is probably, I would say, the most important factor when you're designing an LNA, and these devices offer the lowest noise figure available to engineers. In addition, we also offer integrated ESD protection in these devices,
okay,
which help improve the yield in the factory. And we also offer these devices in one of the smallest packages available today.
Great. So, Andrew, Infineon has more than just RF transistors in its wheelhouse, right?
Yes, we do. In fact, we also offer RF switches and RF diodes along with TVS diodes.
Great. Okay, so let's dive into some specifics about your RF transistors.
Sure, I'd be happy to do that for you. So, basically, the 8th generation of our parts have 3 different devices, our 840, our 842, and our 843. Now, the 840 have been specifically designed for 5 gigahertz WLAN applications.
Okay.
And the 842 have been designed specifically for 2 gig, or 2.4, I should say, applications. And then our 843 is what we call a dual band device, which allows the customer to design an LNA that will operate across a really wide band. In fact, this means that they can design an LNA that operates from 2.4 gigs all the way up to 5 gigs. And you'll notice here as well that in the package styles, we offer, again, one of the smallest packages available on the market, the TSLP package.
Cool. So just a second here. It seems like you've got 3 different package styles here. What's up with that?
Yes, absolutely. Basically, that's engineering preference.
Okay.
But of course, the smallest package style allows the engineer to use the least amount of space in their design. And if that's a key consideration, we provide that for them.
Great. Okay, so Andrew, can you show us an example of what one of these devices would look like in an LNA application?
Sure, absolutely. Let's take our BFP 840, for example.
Okay.
What we have here is an LNA that operates in the 5 to 6 gigahertz band, and it's summarized in our application note 317. What we'll see here is that this particular design offers 1 dB of noise figure, and it has a rejection on the front at 2.4 gig, providing about 15 to 16 dB of gain in the 5 gig band.
Okay. And what if I want to check out this part? Have you got an eval board for me?
Yes, absolutely.
So, can you show us another example, maybe for 2.4 gig?
Sure. Let's look at the BFP 842, which has been designed specifically for the 2.4 gig band. You'll see here that the LNA design that we have is designed for 3 volts and provides about 0.7 dB of noise figure. This design, because this part, this 842, has been pre-matched, this part allows the engineer to design an LNA with a very minimal amount of matching components.
Nice, okay. You said you also had a dual band part, is that correct?
Yes, we do, and you're referring to the BFP 843.
Ah, okay.
Now, what I have here is a wideband LNA design based on the BFP 843. This dual band design offers performance at both 2.4 gig and 5 gig. It provides about 1 dB of noise figure and is operated at 3 volts. Again, because of the 843's pre-matched feature, this design as well uses a very minimal amount of components,
okay.
Again allowing the engineer to save on space and BOM cost.
Very nice. So let me get this right. For each of these 3 parts, you have a demo board and an application note?
Yes, absolutely.
Okay, Andrew, recap this a little bit for me.
Yes, absolutely. Our 8th generation parts have 4 key characteristics that we're very proud of. Gain, very low noise figure, integrated ESD protection, and a very small package. As a result, this makes us the leader in RF transistors.
Fantastic. Well, I think that's all I have time for. Thank you so much for joining me today, Andrew. It was a pleasure speaking with you.
Thank you very much.
Before we go, don't forget to click that link. There you can download several application notes that further expand on this topic. For Chalk Talk, I'm Amelia Dalton. For more Chalk Talks, check out the on-demand section of eejournal.com.